Hello students, in this video we are going to study about the physical properties of alkenes. First, about the physical state. These are the double bonded compounds which are colorless, odorless in nature. But ethene is an exception because it is a colorless gas but has faintly sweet odor. The first three members of the alkene group are gases in nature. The next 14 members are liquids and the remaining alkenes are solid in nature. That means the higher members are solids and the lower members, that is the first three members of the alkene group, are gases in nature. That means when the number of carbon increases, first members are gases, then the next members are the liquids and the higher members are solid in nature. So that is about the physical state of alkenes. Next, about the solubility. Alkenes are insoluble in water, that is due to their non-polar characteristic. As we have already learned for the case of alkane, because of being non-polar, it is insoluble in water. But here, as like an alkane, these are completely soluble in non-polar solvents like benzene, chloroform, etc. The next physical property, that is polarity. Alkenes are weakly polar just like alkanes but are slightly more reactive than the alkanes due to the presence of double bond. As being non-polar, but in compared to the alkenes, they are reactive because in alkenes there is double bond. From this, one of the bond is sigma and the other one is pi. So the pi bond, we have already learned that pi bond are weaker than the sigma bond. When we compare the strength here, pi bond is weaker than the sigma bond. That's why this pi bond can easily break up and it will shows the greater reactivity. So it is a non-polar, like we can say just a weakly polar like alkanes but are slightly more reactive than alkanes. That is due to the presence of the double bond. Next, about the boiling point, which is a very important point in the physical properties. The boiling point of the compound increases as the number of carbon atom in the compound increases. We have already learned in the case of alkane, the number of carbon atom increases, therefore the boiling point also increases because there is increase in the surface area. And when the alkenes are compared with the alkanes, it is found that boiling point of both are almost similar, as if the compounds are made up of the same skeleton, because if being have same number of carbon and hydrogen, so almost the boiling point of alkenes and alkanes are same. The boiling point of the straight chain alkenes are more than the branched chain alkenes, as just like the case of alkane. So the concept of boiling point depends upon the mass, the molar mass. So we can learn this in this way, as the number of carbon increases. So what we can say, the boiling point also increases. If the branching increases, if branching increases, the boiling point decreases because there is a change in the surface area. So this is all actually what we have learned the point in the case of already we have learned in the case of alkane. So we can say that the alkenes, when it is compared with alkanes, they have almost similar boiling point. The next, we will be going to sort out the important points of physical properties of alkenes. That is, alkenes are non-polar compound, as we have learnt. It is insoluble in water because it is being non-polar, it is insoluble in polar solvents like water, but it is soluble in non-polar organic solvents like benzene, and they are less dense than the water. And when you compare the physical state, the lower members, that is the carbon numbers is less than the 4 or equal to 4 are gases, and the higher members like 5 to 17 carbon are the liquids, and the higher members, that is the carbon number more than 18, alkenes are solid in nature. So what we have learned that when the number of carbon increases, the higher members are solid, but the lower members are gases in nature. The alkenes has a boiling point which is small number of degrees lower than the corresponding alkenes. So this is all about the physical properties of alkenes. So this is all about this video. Have a nice day.